Good morning, everyone. How are you guys doing? Did you enjoy the fireworks? Great, great. Okay, so my plan for today is to finish chapter 5. It's only two sections, 5.1 and 5.3. And then I posted the solution for exam 2 on Brightspace just now. It's actually the exam from Marco. He got almost perfect score. So instead of me making a solution, I just used this. So if you have any question about the exam, you can look at the solution on Brightspace and you can ask me tomorrow. And our final exam is 3 days from today. 2 days from today. It's on Thursday. And the homework, few of them are due, I think chapter 4 due tonight. And if you missed anything from before, I open everything and made the due date tomorrow. I definitely will not open anything after tomorrow because if you fail the final exam, there is no point of doing the homework anyway. So you have to finish everything by tomorrow midnight so that you have at least Wednesday to study for the final exam. Okay? Any question? I think so. Till tomorrow. So in section 5.1, they talk about all identities. And then in 5.3, it's about solving trigonometric equation. So there are the first 8 identities you already know. The first 6 is called reciprocal identities or inverse identities. And then we have next to quotient identities. So where we write sine and where we write tangent and cotangent in terms of sine and cosine. And then the new identity starts from the bottom right. Pythagorean identities. Sine square plus cosine square equals to 1. That's the main Pythagorean identities for trig function. And then we have two related identities. One is 1 plus tangent square. If you add 1 with tangent square, it turns into a secant square function. If you add 1 with cotangent square, it turns into cosecant square function. But the most important one is sine square plus cosine square equals 1. So if you add sine square and cosine square, the result is always 1. And then we have more identities, odd and even function, odd or even identities. Since sine and tangent are odd function, so is cosecant and cotangent. And the criteria to being odd is that if you substitute x with negative x, the y turns into negative. So sine of negative x is negative sine of x. Sine of tangent of negative x is negative of the tangent x. Cosecant of negative x is negative cosecant of the positive x. And same thing, cotangent of negative, I missed my negative. Cotangent of negative x is negative cotangent of the x. And since cosine is even function, so that's why secant must be even, because secant is the reciprocal of cosine. And to be even, the y value doesn't change for negative x. So cosine of negative x is same as cosine of positive x. The y doesn't change. So is secant. Secant of negative x is negative secant of x. Do you have more? Yeah, few more. Okay. The last type, I believe. Yep. The last type of identities are co-function identities. It means if you move one function a little bit to left or right, it turns into another function. So they're co-function. For example, if you move sine half unit to the left, it becomes cosine, or half unit to the right, it becomes cosine function. If you move cosine half unit to the left or half unit to the right, it becomes sine function. Not half means half pi unit. If you move tangent half units to the left or right, it becomes cotangent. Same thing, if you move cotangent left or right, pi over half, it becomes tangent function. So sine and cosine, they have same graph. If you shift one graph to left or right, it becomes the other graph. Tangent and cotangent, they have the same graph. You just have to shift them around to turn them same. And then secant and cosecant, they are same if you shift them a little bit to your left or right. So one function turn into another function if you just move them a little bit. For example, the normal sine graph without any transformation starts from 0, goes up, goes down, and ends at 0. This is half pi. Now, if you shift this half pi, half unit to the left, then we start our function from here, goes down, and then goes up. It becomes cosine. See, sine and cosine, they are the same graph. You just have to shift them a little bit to make them same. So for cosine, this is half pi. If you move this half pi to left, it turns into sine function again, but it's become negative sine. But they are sine anyway. So if you move to your left or right, whatever, you can make sine function positive, sine function negative. Same thing, tangent and cotangent. But I don't know the shape for cotangent. It's probably the same as tangent. Okay, so in this class, that's all identities. That's all the identities you have to know. And we use them to simplify trigonometric expression, also to solve trigonometric equations. To the left, one more. Okay, now simplifying trigonometric expressions. To simplify, it's better to convert everything in terms of sine and cosine. If you can do that, then we can cancel out so many things. Once you cancel out like factors, then you rewrite everything in the proper position. And if you can get a new, if you can apply new identity on that, then apply the identity, otherwise leave it alone. That's 3 steps of simplifying. Convert everything into sine and cosine if possible. For example, if you get cotangent, don't use tangent, use cosine over sine. If you use tangent, don't leave it, keep sine, make it a sine over cosine. If you have secant, use 1 over cosine. So whatever you have, convert everything into sine and cosine, because that actually helps us to cancel many things. So we cancel whatever is cancelable, and then we rewrite. After rewriting, if we can apply the identities, you do it. You cannot leave it alone. And yep, in the final exam, we are going to simplify trigonometric expressions. And also you're going to solve trigonometric equations. Rizia, Julia, no fun, please. You can use your phone as much as you want, 24 hours after this week. But till Thursday, no phone. Where is Gabriela? Dada Gabriela. Do you know anything about her? Hmm? Oh, oh. I hope she gets better before the final. That is my plan. That was my plan. But we started almost half an hour late because nobody was here almost. So I don't know. But I'll try. Okay, example. Simplify secant x times cotangent x. What should we do? Good. So what is secant in terms of cosine or sine? 1 over cosine. And what is cotangent in terms of sine and cosine? Sine is tangent. Cosine over sine. And then what happens? We cancel the cosine. What is left? Only sine? 1 over sine. And what is 1 over sine? Cosecant. And that's all we have to do. Convert, cancel, rewrite, apply identities if possible. Otherwise, leave it alone. Any question from anyone? Okay, these are simple, so try the next one. Tangent times cotangent divided by secant. No. 1 over secant is what? So tangent is sine x over cosine x. Cotangent is cosine x over sine x. So cancel, 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 cancel. If you want, you can rewrite secant as 1 over cosine, or since everything cancel out, just leave it. We get 1 over secant. That gives us cosine x. Okay. Mhm. Okay. Now we have 1, 2, 3, 4, 5, 6, 7. Try them. Enjoy them, actually. These are fun. So try to use all the identities I just gave you, those, and also for ln, think about the logarithmic properties. Or you can write cosine square as 1 over secant square. The power doesn't change anything, you keep the power if you use the identities. Okay. Yes. Oh, that's it from 5.1. Wow. Once you're done with this, you're done with 5.1. Let's see how long actually it takes you. So from 38, 11, 38, start. Let's see if we can finish them fast, correctly. Two, three, four, 5, 6, 7, 8, 9, 10, 11, 12. Half of the class is missing. We have total 24 students. And here we have 12 students. The class started with 35 students. And then eventually either people dropped it or the registrar dropped them. So I got 24. Do you guys feel sleepy during rainy days? You do, right? So it's not only me. Every rainy day I feel so sleepy. And for some reason I get scared. Like I feel some fear in me, like something bad gonna happen. You do too, Julian? Wow. What is 1 plus 10 square? If you add 1 to this square, it becomes secant square. So let's actually do them together so that we can finish everything today. Come on. Oh, that's why it kept crashing because I had 200 pages. Wow. Okay, together. Secant. What is secant in terms of sine and cosine? So we have 1 over cosine x times cosine squared x divided by, what is cotangent? Cosine x over sine x. You can use 1 over tangent, no problem. But our goal is to use only sine and cosine to make life simpler. So we have cosine cancel with cosine squared. We left with cosine x. So we have cosine x in the numerator. We do keep change flip. Denominator becomes sine x divided by cosine x. And then what happens? Cosine cancel out. Our answer is only the sine of x. Next one, cosecant. What is cosecant in terms of sine and cosine? 1 over sine of x. And what is secant? 1 over cosine x. But since it's square, so you have to write square. Cosine square x. Huh? Sine secant square tangent. Sine secant square tangent. Okay, let's do it together. The different one also. D version 2. Sine of x times secant square x over tangent square x. So let's do the left one and then we are going to do the right one. So cosecant is 1 over sine, secant is 1 over cosine, and tangent is what over what? Sine square x over cosine square x. So we're going to keep change flip. On the numerator, we have 1 over sine x, 1 over cosine square x. When we flip the denominator, we get cosine square x divided by sine square x. Cosine square cancel out. We left with 1 over sine cube of x. And what is 1 over sine? Cosecant. So this becomes cosecant cube of x. Cosecant. Now for the next one, let me change the color actually. We have sine of x times 1 over cosine square of x divided by sine square of x over cosine square of x. So we have sine of x divided by cosine square x times cosine square x divided by sine squared x. Cosine, cosine cancel out. Sine, sine cancel out. We left with 1 over sine. Now that's a single cosecant x. So changing only one function makes the answer different from one another. See here, all we are doing is using identities. That's it. We're applying all the identities and then canceling them. And then again, using identities to rewrite them. Okay, for the next one, we keep our sine because it's already in terms of sine. We keep our cosine because it's already in cosine. And now we change the tangent. Tangent is what over what? In terms of sine and cosine? Sine over cosine. So sine of x divided by cosine of x. So we can cancel actually the cosine directly here. So we have sine squared x divided by sine x. We cancel, we left to it sine of x. So see, most of the answers actually at the end sine or cosine. Not always, but mostly. One over secant square, sorry, 1 over cosine. 1 over cosine square of x minus 1 divided by sine square x. How'd you get 1 over sine square? On the numerator or on the denominator?
Like 1 over.
Say it again. Which identity you are using? Yes. If you use cosine square in terms of sine square, we know sine square plus cosine square is 1. So cosine square is 1 minus sine square. But does it help us? Not really. So what you can do, you can combine them. What do we need when you add a fraction? So what is our denominator here? So I multiply numerator and denominator by cosine square. So we get 1 minus cosine square divided by cosine square x. So keep, change, flip. This becomes 1 over sine square x. Now we are going to apply identities here. The Pythagorean identities. Sine square x plus cosine square x equals to 1. So if you subtract cosine square from both sides, cosine square minus cosine square, we get 1 minus cosine squared x is actually sine squared x. Oops. So the numerator is actually a simple sine squared x. And we have cosine squared x times 1 over sine squared x. So this cancel out. We have 1 over cosine. That becomes secant squared x. That's what you have to do if you use sine and cosine. However, there is also a second method. Oh man. Ah, I have to restart again. Come on. I'm gonna lie, your answer. Yeah, we learned so many things in trigonometry. Okay, so see, there is one identity. 1 plus tangent square is secant square. If you use this identity, then it will be shorter. We know 1 Come on, why my drawing is not drawing? Let me see. Why everything is disabled? Come on. Read only version? Why do I have read only version? refresh. I hate it. Okay, let me get the page instead of doing it on the left. So one of the identities says 1 plus tangent square is secant square. So we can use this identity here. If you subtract 1 from both sides, we get tangent square is secant square minus 1. That means on the numerator, where we have secant square x minus 1 divided by sine square x, it's simply tangent square x divided by sine square x, because this secant square x minus 1, which is here from the identity, is same as tangent square. And now it becomes simpler. We have sine square x divided by cosine square x. Keep, change, flip. So denominator becomes 1 over sine square x. Sine square cancel out. We get 1 over cosine square x. That's same as secant square x. So our answers are same from the left to the right. Just methods are different. In the next one, we can use this identity directly because we have this 1 plus tangent square is secant square. And we have our cosine x. So you can rewrite secant square as 1 over cosine square x. So cosine cancel out. We left with 1 over cosine x. That becomes secant x. That's one method. Or from this line, you can rewrite cosine as 1 over secant x. And we have secant square x. So secant square, we left with secant x. Our answer is secant x. So you can simplify in many different ways. Or if you want, you can convert tangent square to sine square plus cosine square. Find the LCD. The numerator will be sine square plus cosine square plus sine square, which is 1. And you have denominator cosine square. You can cancel them. Okay, Ellen, the log. Which properties you can think of when you see this question about log? Log has so many properties, right? Does it remind you of anything? ln of cosine divided by sine. Great. See the minus? Minus means division in log, plus means addition, multiplication. So we have ln of cosine minus ln of sine. So which is same as you're converting it to a single log. Minus means division, so cosine x divided by sine x. And what is cosine x divided by sine x? Cotangent x. They put this absolute value bar because sine and cosine, they have infinitely many cycles. So they have negative side and positive side. It's only permissible to use positive side of sine and cosine. The negative of log doesn't exist. So you cannot use any negative side of the cosine or sine. That's why for ln, we must use this absolute value bar. Means only the positive portion we are taking, no negative portion. Okay, so that's our final answer. Okay, this is the last one, right? Yep. What do you think we should do? The numerator is cosine x minus 3. What can you do on the denominator? Factor. How are you going to factor? Difference of perfect squares. So what factors we get? So cosine x whole thing square minus 3 square. So cosine x plus 3 cosine x minus 3. And then what do you see? The minus 3 part cancel out. We're left with 1 over cosine x plus 3. And here we actually cannot do anything. Denominator is not breakable. If it was numerator, we could break, but since it's not denominator, it cannot break. We have to keep our denominator. So yep, in the final exam, you're going to have at least one of them. So that's why you need to remember your identities. With this, we are done with section 5.1. And now we are going to do, can I flip my page? Are you guys done copying? Okay. Now we are going to solve trigonometric equations. To solve trigonometric equations, use standard algebraic techniques whenever possible. For example, collecting like terms, taking the square root if square is given, factoring if it's factorable, all these things. Like how you solve normal algebraic equation, we are going to solve the trigonometric equations that way, similarly. The difference is that when you get to the last step, for example, sine of x equals 1, then you have to find out what is the x. So you're going to invite the arc sine inverse. And that time we don't have to worry about the inverse function, the range of the inverse function. Because we are not working with the range of the inverse function, we are working with solving the angle. So our main goal is to isolate the trig function on one side of the equal sign so that we can invite that inverse function. Once the trig function is isolated, we are going to find all the angles that satisfy the condition. For example, if you have at the end, let's say sine of x equals 1/2. Basically, we want to know sine of what angle has opposite 1 and hypotenuse 2. So 30 degree. So our angle is 30 degree. But that's not the only solution. Because sine is continuous, right? Forever on the left, forever on the right. So how many 30 degrees we have in our entire number line, entire cycle. 4, we have so many, like if it's going on forever and ever and ever and ever and ever, we have infinitely many 30 degrees. So we know only one 30 degree, but the answer is not 130 degree, it's infinitely many 30 degrees. So what we do, we take this 130 degree and we keep adding 2 pi with that. So usually we look at the solution in 0 to 2 pi. In one cycle, how many things we have that satisfy this condition, we keep them, and then for the rest infinitely many solution, we add 2 pi. For example, here, let me draw clearly. Let me get a page here. Insert. Come on. $200 pages. One page. Okay. So for example, if you look at only one cycle of the sine, it goes up, goes down, and here, right? That's one cycle from 0 to 2 pi. Now we know highest is 1, lowest is -1, -1. Right? Now when you're looking for 1/2, that means we have 1/2 here. So for this 1/2 number, how many sign value we have? One sign value here, another sign value here, right? So in one cycle, we have two angles that have the same result. Opposite 1, hypotenuse 2. So in one cycle, we're going to have two solutions. One is 30 degree, and what's the other degree? On which quadrant? On -30. If you look at the unit circle, we have 30 degree here. We have x values 30 degree. X is 30 degrees here, right? X is √2/2. X is √2/2 and y is 1/2. Which other quadrant has y 1/2? Quadrant 2 here. Huh? It's -√3/2 and positive 1/2. So if this is 30 degree, we know, then how much is the big one? 150. So we actually have two solutions, 30 degree and 150 in one cycle. Okay, so if they ask you to find the solution for one cycle, we have to find all of them. And we have to find all of them anyway, always. And if they do not mention the domain, what's the domain of our solution set, then our result will be x plus 2 pi n. So not x, 30 degree. Laminate nicely. X is 30 degree. Oh, sorry. We actually cannot give the answer in degree because the solution must be in radian. Every time you solve a trigonometric equation, the result must be in radian unless they mention to write it in degree. So 30 degree is what in radian? Pi/6. So 30 degree we know, but the answer is actually pi/6. And we are going to add 2 pi n. Because after every cycle in every 30 degree, we're going to have this solution. And there's another solution, 150 degree. That will be harder, right? 150 degree is 180 divided by pi. 0, 0 cancel out. 3 goes to 5, 3 goes to 6, right? So we have 5 pi/6 plus, this is one cycle, but we have infinitely many cycles, so 2 pi n. Because after every 2 pi, the cycle restarts, right? That's how we do solution, we keep adding 2 pi. N means n equals 0, 1, 2, 3, 4. to infinity many numbers. So you have to mention n starts from 0 or 1. When n is 0, our answer is only 5/6 and 5/6. And then when n is 1 means you're looking at 2 cycles. So we have 2 solutions. I mean 4 solutions. So that's the rule for trigonometric function. Get your trigonometric function alone on one side of the equal sign. If you know the answer, like this one half, we know easily. It's 60 degrees, 30 degrees, right? So if you know the answer, just do it mentally. If you don't know the answer, for example, if I give you sine x equals to 5/7, do you know what is 5/7 for sine? No idea. So we have to invite the inverse sign. So we apply inverse sign to both sides. That way we did to solve angle of elevation, angle of depression, remember? So you invite inverse sine, inverse cosine, and inverse trig, and then you get the result in radian mode. Always the result in radian mode. Okay? So that's all about the background information. So here I said when solving equation involving cosecant, secant, cotangent, or even tangent, it's helpful to use sine and cosine. We know why, because you see many examples we did for simplifying, and then the result became very simple one if you use sine and cosine. And then try to solve it. Once you solve, make sure to write in radian mode the answer. And since it's periodic, so you have to add 2 pi n for every answer. So we have several types of quadratic functions, several types of trigonometric function. One is quadratic type. For example, ax squared plus bx equals c. If we have that format, your goal is to factor this quadratic into 2 pieces and then take each piece, set them equals to 0, solve for your angle individually. So how do you know we have a quadratic format? Well, if you have a square and a single one, a constant, it follows the quadratic format. So every quadratic mostly are factorable in this class. So factor them, satisfactory equals to 0, solve for us. That's one type of quadratic equation. Sorry, one type of trigonometric equation. And then we have normal DCF, like sine square plus sine. You can take out sine as a common factor. And then, yeah, let me say that. If your domain is not mentioned for the solution, you have to keep adding 2 pi n. But if it's already mentioned that from here to here, then you just have to find exactly those solutions in your domain. Usually, the domain is from 0 to 2 pi, usually, but not always. They will mention definitely. If they don't mention, that means it's general solution, means infinitely many solutions. An integer, it means -2, -1, 0, 1, 2, all these numbers, whole numbers, positive and negative. Can I flip my page? Can I? Okay. So let me just answer and try doing this. We have 13 cosine x plus 7 minus cosine x. So if you ignore the cosine, basically we have 13x plus 7 equals minus x. So in algebra, how do you solve this type of equation? What do you do? We need to bring everything to one side. So we are going to add cosine x to both sides. Let me erase this. So before we had 13 cosine, now we are adding one more cosine. So how many cosine we have? 14 cosine. 14 cosine x plus 7 equals 0. And then to get the cosine alone, what do we do? subtract 7, we get 14 cosine x is -7, and then divide by 14, the cosine x. When you simplify the right side, what do you get? -1/2. It means we have adjacent 1, hypotenuse is 2. So which angle has x value 1, x is 1, so 60 degrees. All right. So if you use your hand, x is 1 means we have left side 1 finger. So we have left side 1 finger, that means our angle must be 60. So you look at a cosine graph. -1/2 is here. How many solutions you are going to have in one cycle? 2. One is here, one is there. Okay, so our x is, we know this is 60 degrees, but it's negative. So if you look at the unit circle, where cosine is negative, on which quadrants? Here and here. No, here and here, right? So we have a 60 degree here. And we have another 60 degree here. But we cannot tell them. Our answer is 60 degree on the second quadrant and 60 degree on the third quadrant, right? That's not the formal way of saying. So we actually need an angle that starts from here. What's the angle? So this is 180 minus 60. 180 minus 60. That is 180 minus 60, 30 degree, right? No, sorry. 8 minus 6 is 120. So 120 degree, and you are adding 60 more. So this one is from here to here, it's 180 plus 60. 240? 240. But we cannot write them in angle in degree notation. So we know our answer is 2 of them in one cycle. Did you guys understand how did I figure out 2 answers in one cycle? I verified with my graph. The graph says this is the cosine graph. -1 that is here because the lowest is -1. So from the graph, I know I have 2 definite solutions. With the graph, you can figure out how many solutions you have. Okay, that's what graph is helpful. So since we know into solution, now it's time to figure out what are those solutions. So we go to the unit circle. In the unit circle, we have the answer. But before we go into the unit circle, we can first figure out what's the angle we have, the reference angle. Cosine is adjacent over hypotenuse. So cosine is x. If you look at your finger, we want one finger on the left. One finger on the left is here, and that should be our angle. So this is 0, 30, 45, 60. So our angle definitely is 60 degrees. But it's negative. So in which quadrants our cosine is negative? Cosine is negative in 2 quadrants. Cosine is x, remember? Come on. 2 and 3 actually. Cosine is x. So x is positive here, x is negative here, x is negative here, and x is positive here. So we have our solution here. 260 degrees, one is on the second quadrant, one is on the third quadrant. But since we cannot tell them that one solution is here, we need an angle that starts from the 0 degree. We know definitely this one is 60 degree because we know it from our hand or from a special triangle, whatever. So this red one is 180 minus 60 degree. So we have 120 degree here. That's one angle. See here? This one is 120 degree. But we have another solution. So we go from 0 degree all the way to another 60 degree here. This blue angle is 180 degree plus the 60 degree. So we have 240 degree. So two solutions, 120, 240. But we have to write them in radian mode. So 120 times pi over 180 and 240 times pi over 180. What do you get? 0, 0 cancel out. 0, 0 cancel out. 3 pi over 4 and 4 pi over 3. Did it mention our domain for the answer, for the solution? Didn't mention anything. That means it's general solution. So it's 3 pi over 4 plus 2 pi n. I don't have space, so let me actually do it on the right side. So x equals 3 pi over 4 plus 2 pi n and 4 pi over 3 plus 2 pi n. That means it doesn't matter how many cycles you take, you definitely have 3 pi over 4 plus extra more. Huh? 3 pi over 4. So you divide it by 6. I trusted you guys. It's 2 pi over 3, right? Divided by 6 is 2, divided by 3 is 3. So 2 pi over 3. 2 pi over 3. And the next one is correct, right? Divided by 6 is 4 and 3. Yeah. Thank you. Good catch. 2 pi over 3. Any question? So what I personally do is, first I verify how many solutions I have using the graph. Because sine and cosine graph is easy to remember. Using the graph, you can figure out how many solutions you have. And then using the unit circle, we get the location of the angle, where the angles are located. We can find out the rest. For example, if I give you sine x equals 0, what's the answer? How many angles do you have? Sine x equals 0. How many solutions you think like we can have? That's the only solution? No, in one cycle. In one cycle, how many angles gives us? So 2, are you sure? Why do you think it's 3? Solve for x. Sine x equals 0. What is your x? That's why I like my graph. Let's draw the sine graph. How many zeros we have? 1, 2, 3 zeros. So as exactly, sine is y. From 0 to 2 pi. 0, this is pi, this is 2 pi. So answer is 0, pi, 2 pi. See? Without graph, none of you could tell me that we have these solutions. Mm-hmm. 0 and 360 has same answer, but it's 2 types of angle. So you have to give me 2 answers, not 1. It means we have cosine graph. It's going on forever and ever and ever, right? We know our one solution is here, another solution is here. But also this solution has another solution here, and this solution has another solution there. The difference from here to here is 2 pi. From this solution to this solution, the difference is 2 pi. Or from here to here, the distance is 2 pi. From here to here, the distance is 2 pi, like somehow. From here to here and here to, no, from here to here is 2 pi, and from here to here is 2 pi. So after every 2 pi, you're going to have the same answer again. -1/2, -1/2, -1/2. So that's why you have to keep adding 2 pi m. Means after every 2 pi, you're going to have the same result. So this angle plus 360 degrees, plus 360 degrees, plus 360 degrees, plus 360 degrees. You're going to have the same result. For tangent, you add 1 pi. Sine and cosine, their period is 2 pi, right? Without any transformation, it's always 2 pi.
If there was a deep transformation from sine or cosine, would be added to.
If it's a transformation, then between the one transformation equation, we just solve for x, and we use the original equation. Fine. So see here, I mentioned my domain. It's from 0 to 2 pi. So look at only 0 to 2 pi and tell me how many solutions you have. So if they don't give you the domain to look at, the answer is everything infinite. But if you do have a domain, your life is simple. You only look at that cycle, that domain they are mentioning. Sometimes they tell you from -2 pi to +2 pi. So you draw 2 cycles and see how many solutions you have. So the domain is important. Domain gives you limited solution. Without domain, you have infinite solution. So add 2 pi n for every result you have. Okay, one more question, and then you're going to do example by yourself. Solving for x-intercept. Come on, what's wrong with this? See, I'm drawing here by working on the left page. Yeah, I should do it. Let me do it here so it will work on the left page. That's a good idea. Page 3. Okay, so cotangent square -1, 3 cotangent square x -1 equals 0. Step 1, move 1 to the other side. So we're going to add 1 to both sides. Or you can use the identity, but we cannot use because 3 cotangent. The identity is only for 1 cotangent. Okay, so we have 3 cotangent square x equals 1. Divide by 3, divide by 3. So we have cotangent square x is 1/3. Square root. So we have cotangent x is 1/√3. But anytime we take the square root of a variable, how many solutions do you have? How many possibilities do you have? Plus, minus. We did it on the whole thing. But what is square root of 1? 1. So 1 square root get vanished, but square root for 3 doesn't get vanished. Okay, now cotangent 1/3. In terms of triangle, cotangent is what over what? Adjacent, no, cotangent is opposite of tangent, right? Opposite, right? I thought hypotenuse. So this is opposite and this is, no, other way around. Adjacent over opposite. So 60 degree. But we have plus and minus. So plus 60 degree and minus 60 degree. We have 4 choices. So one of them is positive 60 degree. So if you look at the unit circle, we have 160 degree here. We have another 60 degree here. That's minus 60 degree. We have another 60 degree here. That's also minus. And we have another 60 degree here. So how many solutions are you supposed to have in one cycle? 4 of them. So 160 degree is direct. But for the next 60 degree, what's the angle? 180 minus 60, that gives us 120. Then we have, let me change the color. Another 60 degrees here. It's 180 plus 60, that's 240. And then we have another 60 degree from here to here. So it's 360 minus 60, that gives us 300 degree. And then you have to convert all these degrees into radian, and then they all will have plus 2 pi. Plus 2 pi n. Plus 2 pi n. Did I make a mistake? Cotangent is positive on the first and fourth quadrant, first and third quadrant. It's negative on the second and third quadrant. Let me see the solution. Oh, not 2 pi, because they have cycle 1 pi. So it should be 1 pi n plus 1 pi n. Tangent or cotangent, they have 1 pi cycle. Okay, so why the answer is only 2 of them? Right, because their graphs are like this. So they don't have 2 pi, they have only 1 pi. So we only need two of them from here, and you keep adding 1 pi. For example, for this angle, this will be given already. So we need this one and this one. If we add 180 here, this angle becomes this angle, right? So we don't need the angle on the third quadrant, we only need the angle on the first quadrant, which is 60 degrees, which is pi over 3. And then we also need the angle on the second quadrant, which is 120 to pi over 3. But we don't need the angle here because the 180 gives us this angle. The first quadrant gives us the angle on the third quadrant after adding 1 pi. The second quadrant gives us the angle here after adding 180. And our cycle is 180, 1 pi. So you only need two answers, first quadrant and the second quadrant. The rest will be added with 1 pi n. So answer is only these two. If you want, you can keep writing them, the rest, but the main two angles are the first quadrant and the second quadrant. So if you give more, it's not a problem, but if you give less, then it's a problem. Okay, so in the final exam, usually they give domain. So you're only going to look at from 0 to 2 pi or negative 2 pi to positive 2 pi. So either under 1 cycle or 2 cycle. That's it. Okay. This one is GCF because they both have cosine. This one is also GCF because they both have sine. This one you combine like terms. This one is quadratic. No, GCF because they both have cosecants. Okay, GCF. And then I should do one where we have a quadratic. So let me change one of these. I'm going to do it later. Yeah. Oh, I didn't mean that. Let's see. Okay. Okay. So try this by yourself. This one is quadratic. Okay. So you need to use identity. And this one is also you need identity to convert them. Identity. Okay. So enjoy doing them. See how much you can do. And these are simpler because you only look at one cycle from 0 to 2 pi. And for tangent, it's two cycles because tangent and cotangent, they have cycle 1 pi. So try solve for x, and most of them are non-calculated questions. And all of them, I think, non-calculated questions. So all you have to do is get your trig function alone once you solve them. Cosine of x. So just like the normal algebra, if you have 2xy minus x equals 0, how are you going to solve? Similarly. So DCF means greatest common factor. Quadratic means you're going to factor this way, but first you need to use identity to have only one. So our goal is to have only one trig function in each factor. Whatever, try your best, okay? You don't have to work alone. You can work out the neighbor and everything. And I will be back. Who else came late? Gabriella, Molina, Stephen, Hector, Ali, Angela. Are you guys done or are you guys stuck? Which one? Okay. Let's do them together since we don't have much time. So sin x cosine x minus cosine x. As you see, we have a GCF. So factor out your cosine x. So what is left? minus 1. Great. So just like normal algebra, when you have your factors, you set each factor equals to 0 to solve for the variable. So cosine x equals 0 to sine x minus 1 0. So here we only need to find angle, and here we get sine x is 1/2. So what is our angle? So for me, I would like to see how many angles we have for each case. For cosine, starts from here, there, 0 are here. So it's supposed to have two answers. And it's simple. So this is 2 pi. Exactly in the middle, we have 1 pi. So this one is half pi. And the next one will be 3 half pi. So one answer is half pi. The answer is 3 half pi. Now for sine, let's see. Sine goes up, goes down, ends, and we're looking for 1/2. If this is 1/2, we have one angle here, another angle here. So for sine, we are going to have two answers. Now sine is opposite of our hypotenuse. Also, it's y value, y. So we have y means bottom. We have bottom 1, so that must be 30 degrees. So one of them is 30 degrees here. So 30 degrees. And the other one, it's less than 80 degrees, right? Because this is 80 degree pi. So less than 80 degrees means 180 minus 30 degrees. 180 minus 30 degrees, two of them. So 30 degree and 150, right? 8 minus 3 is 5, 150 degree. But the answer must be in radian. So convert. 30 degree is simpler. It's pi over 6. And 150, I have to calculate actually. 180 pi, this cancel out. We have 3. So 5 pi over 6. So we have total 4 solutions. Pi half, 3 pi half, pi over 6, 5 pi over 6. 2 for each. Guess what? Tomorrow you're going to have a quiz on this. On simplifying Trig expression and solving. There will be more solving questions because in the final exam you have at least 2, I think, solving questions. One maybe in the calculator part and one in the non-calculator part. So these are non-calculator part. Half an hour. Non-calculator. The quiz will be on non-calculator. Oh, so I'm going to modify the calculator and convert everything into 100% skill. So you can convert the new score with in 100% skill. So you don't have to worry about like which one or more. And if you have all perfect score in the quiz, you don't have to take the quiz if you don't want to. But if you don't have perfect score in the quiz 1 and quiz 2, definitely take it because that's going to replace the bad one, the worst one. Okay. Or GC. We have cosine, right? In both terms, we have cosine. So factor out cosine is a common factor. From the first factor, we left it sine x. From the second factor, we left it 1. So GCF, that's why I wrote here, GCF. Our GCF is cosine x. So factor out cosine x. Okay, so remember, tomorrow, don't be late tomorrow because I'm going to give the quiz from 11 to 11:30. if I'm not late. Okay. If I'm late, then we'll start late. But if I'm not late, the quiz will be from 11 to 11:30. Okay, the next one, sine square and sine, they both have sine in them, so this is also GCF. Our GCF is sine x, so you factor out sine x, and what is left? Another sine x with the 2 in the front, plus 1 equals 0. And just like the previous one, we take each one of them and set them equal 0. 2 sine x equals -1. So we just need to find x, and here x is -1/2. Now, since they both are sine, so I can draw only one sine graph and I can figure out how many solutions it's supposed to have. So for sine 0, we have 1, 2, 3. There are 3 solutions. 0, pi, 2 pi. However, see here, 2 pi has in parentheses, means we cannot use 2 pi. So 2 pi is out. And for 1/2, if this is -1/2, -1/2, so we have one solution here, another solution here. Opposite of our hypotenuse. So we already did that in the last example. We definitely know this is kind of one of them. But since sine is negative, so we're supposed to have 2 big answers than 30 degrees. See here, this is 180 plus 30 more. This one. 180 plus 30. And this one is 360 minus 30. Oh, graph actually helps us to find out the answer. Ooh. So this, let me do it nicely so you can see the graph. This is -1, this is +1, but we are looking at 1/2. In the graph, this is 2 pi, this is 1 pi. Pi means 180 and 2 pi means 360. So we have one solution, which is 180 plus the 30, and we have another solution, 360 minus 30. See? So 180 plus 30, 210, and 360 minus 30 is 330. Now all you need to do is find them in radian mode. So we get 2 solutions from zeros, 1, 0, 2, 0, this, and you have 2 solutions from -1/2. One is 180 plus the 30, one is 360 minus the 30. And I believe these are 7 pi over 6 and 11 pi over 6. So 2 answers, 2 answers. So yeah, we actually don't even need the unit circle. The graph tells us all the information. Because here the domain, it says from 0 to 2 pi, but do not include the 2 pi. If you had 0 to 2 pi with bracket, then we could take 2 pi. But parentheses means do not take it. Okay, so it's not bad actually, is it? Let's do a few more. We have same function, so bring function to one side, number to the other side, just like normal algebraic equation. We are going to add 4 cosine x. So cosine will be together. And we can add 5. So numbers will be on the other side. So 2 cosine x and 4 cosine x. How many cosine x do we have? 6 of them. Come on. So 6 cosine x in one side, and we have -2 plus 5. What do you get on the other side? 3. Please stop playing. Yeah, from tomorrow I'm going to make new slides to review. Okay, so we have 6 cosine x equals 3. We divide by that, so we get cosine x equals 1/2. And only its positive solution. So let's look at the cosine graph. Goes up, goes down, stop. This is -1, this is +1, and you're looking at +1/2. Here is +1/2. So you have one solution before 180 and one solution after that. So we have, this is quadrant 1. This is quadrant 2. No, so this is pi. No, this is pi. This is half pi. This is 3/2 pi. And this is 2 pi. So if I split into 4 pieces, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So we have two solutions. One, oh, my bad. The first one I wrote wrong. The first one is before 180. Before 90, sorry. Yeah. So two solutions. One is on the first quadrant, and one is on the fourth quadrant. Right? Oh yeah, cosine is positive only on the first and fourth quadrant. Yeah. So which angle x? X means on the left. On the left, you have one finger. So which angle is this? 60 degree. So definitely one of them is 60 degree, which is pi/3. And the other one will be -60, but we need a positive angle. So this one is 360 minus 60. That gives us 300 degree. Do you know what angle is this? 300 and then 180 divided by pi. 11 pi. It's 5. Okay. 5 pi/6. 5 pi/3 actually. Because we are dividing by 6. So 1 pi/3 and 5 pi/3. Who is last? Tell me which part was confusing. So which angle has adjacent one? Now definitely one of them is 60 degree with a positive one. Right? And then we have another 60 degree on which quadrant our cosine is positive. If you look at the circle, on which quadrant our x is positive, cosine is x. So definitely in quadrant 1, our x is positive, and which other quadrant we have positive x? Positive x-axis. Look at the positive x-axis. No, 2 has negative x-axis. 3 has negative x-axis. Look at your axis. This is positive x, right? So which two quadrant has positive x? 1 and 4th. So you have two solutions. One is on the first quadrant, one is on the fourth quadrant. Now for the first quadrant, all that is easy because that's our solution. For fourth quadrant, our answer is negative 16. We cannot solve the negative 16. This is the criteria. So from here to here, still 60 minus 16, 300 degrees. The two solutions, 60 degrees and 300 degrees. Convert them into radian. For this one, we have sine 0 and sine negative 1 half. Now, if you look at the quadrant, sine is y. Y is negative, right? Y is negative here and here, right? Y. This is negative y, this is positive y. So this negative y is in the quadrant 3 and quadrant 4. So which angle has opposites? 1. Opposite is 2. 30 degrees. Definitely one of the angle is negative 30 degrees and the other angle is negative 30 degrees here. But it cannot be the negative angle. So you take from here to here, that's one angle, and from here to here, that's another angle. So these are the two angles we have, 180 plus 30 and 360 minus 30. Because this angle is 180 plus 30 more, and this angle is 360 minus 30. Okay, let's do a few more. I actually forgot the quadratic one, so let's go back and do the quadratic here. So we had 2 sine squared x plus cosine x equals 0. Now we have two different angles, two different trig functions, right? Our goal is to convert everything into one trig function. So which one we can convert? Sine into cosine or cosine into sine? But then we still have two different angles, two different trig functions. You have to convert both of them into one function on one side. So which one we can actually convert? Cosine to sine or sine to cosine? For which one we have an identity? For sine square or for cosine?
Square.
Sine square, that means we can work with sine square. Can we use an identity that converts sine square into cosine? The identity is sine square plus cosine square equals 1. We are given the sine square. If you subtract cosine square from both sides, that tells us that sine square is actually 1 minus cosine square. We use the Pythagorean identity. We can convert this sine square into 1 minus cosine square. Pythagorean. Scroll through your images and see Pythagorean identity. The sine square plus cosine square equals 1. The identity says sine square plus cosine square equals 1. Don't tell me 1 is on the right side, but you wrote 1 on the left side. Does it matter? Exactly. So subtract cosine square from both sides from the identity. So what is sine square? Exactly. So instead of writing sine square, write 1 minus cosine square. And we have 2 in the front. And we have cosine x on the right equals 0. And now we're happy because we have only one function, cosine. So we distribute the 2. 2 minus 2 cosine square plus cosine x equals 0. So we have negative, if I write nicely, -2 cosine squared x plus cosine x plus 2 equals 0. I just rewrote in decreasing power order. And then we don't want the negatives, so we can multiply both sides by -1. We get +2 cosine squared x minus cosine x plus 2 equals 0. Let me put 4 here so you can actually solve it. Okay. Without 4, it's not factorable, but if you put 4, it's factorable. Oh, sorry, my bad. This should be minus. Then 4 doesn't work. 2 times 2, 4, 2 times 2, 4. Let's put 3, then it will work. 4 doesn't work. 2 times 2, 4. Which two numbers multiply to 4 and convert to 1? I mean, add up to 1. That's possible. But 3 is possible. 3 will work, actually. What will not? 3. Now it's going to work. 2 times 2, 4. So 4 times 1, 4, 4 minus 1, 3. Yeah, it's going to work. But your 2 is AC method. Do you guys remember your AC method? Okay. Let's do some sidetrack. Let's say we have 2x squared minus 3x minus 2. The AC method says multiply a with the c, means the coefficient of the highest degree with the constant. So we get 2 times 2, 4. Split that into 2 pieces, so when you combine, the result will be the middle one. So which two numbers, when you multiply, you get -4. Multiply to -4. When you add, the result will be -3. Which two numbers? -4, +1. So what you do is this 2x squared minus 3x minus 2 equals 0. We rewrite this 3x as minus 4x plus 1x. That gives us -3x. And we have 2x squared and we have minus 2 equals 0. We are using AC method of factoring to factor. Now, once you have 4 terms, you go to grouping method. It takes the first 2, make one group. It takes the last 2, make another group. And use GCF for both. In the first group, what is your GCF? Means what factors you see. In the first group, why do you see -2 in the first group? 2x. What is left when you factor out the 2x? No, from x squared, you took out the x. What is left? X minus 2. Your second group starts with a plus sign. So you are going to do plus And what's the common factor in the second group? Nothing means 1. Factoring means dividing. You can divide both of them by what? By 1. So you factor out a 1. And you rewrite x minus 2. Probably they will give you this one also with AC method. You're supposed to know the AC method. Come on. You just came from algebra. Every algebra student must know AC method. So same two group. What do you see now? Do you have anything in common? X minus 2. So you take out x minus 2. Then what is left in the first group? 3x. And in the second group? Plus 1. That's the two factor you have. So yeah, utilization memory, guys, is the AC method. Now see here, I have 2x, 2 cosine square. So if our x is cosine x, then this becomes cosine x minus 2, 2 times cosine x plus 1, right? I did the math like algebra, but from here to here, how does it go? 2 cosine square times 2x square. What does it mean? X is a cosine. You find out that. Because you have to AC method here. So if you don't want to use AC method, you can find out what other methods you can use. You find out, do you have any other methods? I can show you a shortcut AC method, but that might give you more trouble. You can't remember well. Let me just show you. If you can't remember, it's on you. Don't worry. Insert. Yep. Okay, so if you don't want to do all this hard work, there's actually a shorter method. So we have 2 cosine squared x minus 3 cosine x minus 2 equals 0. You have to use AC method anyway, A and C. So 2 times negative 2 is negative 4. And we know we have to have negative 4, positive 1 to get this middle 3. At least this part is easy, right? Figuring out the two numbers. Now, once you figure out these two numbers, you're going to split your cosine square into 2 pieces. One is cosine x, one is cosine x. So we are going to make 2 pieces of parentheses. And now we are going to split this these 2 into 2 pieces. 2 and 1. Okay. Split cosine square into cosine and cosine. Split 2, 2 and 1. 2 times 1 is 2. Cosine x times cosine x, cosine square. And oh, no. We don't do that actually. Sorry. Not that. Forget about this. We use this. One of them get negative 4, one of them get positive 1. That's why we splitted them. Now what to do, we are going to divide them by this A. Divide by A. In our case, how much is the A? 2. So divide by 2, divide by 2. What is 4 divided by 2? So one of the factor is cosine x minus 2. The other factor is cosine x plus 1/2. That's it. Try to solve for x. Cosine x is 2. Cosine x is negative 1/2. Simple. And then you figure out which angle gives you 2 and which angle gives you negative 1/2. So cosine is adjacent of our hypotenuse, right? Can you have a triangle that has hypotenuse 1, but the adjacent is 2? Impossible. Hypotenuse must be the longest side. So that means you have to solve for only one of them. Cosine. Cosine is negative on which quadrant? Cos means x. 2 and 3. So how many solutions we have? 2 of them. Which angle has adjacent 1? So we have 60 degree on the second quadrant and 60 degree on the third quadrant. So which two angles we have? 120 and 180 plus 60. 240. And then convert them into radian modes. Does it work? Let's see. Oh, we don't have the solution. But it should work. Okay. Same is it. 10:30. Okay, so if you are confused, guys, you still have tonight to study if you want to dual in tomorrow's quiz. Or if you want to just do it in the final exam, you have tomorrow and Wednesday to study, and you'll be ready for the final exam. Definitely 1 or 2 from solving, and definitely one from simplifying. Yeah. That's
You're not that good at simplifying.
I already did that. The lecture, that's the YouTube. Watch YouTube to get the notes. Nothing is free, you know.
You post
I
the
give-
slides?
Yes, it's in chapter 4.
Okay. What time is the final? Did they?
Same time, class time. Past day 11.
Oh, at 11.
Julia. So this net points more than 100, right? Will be added to quiz. And I got 8, and I needed 8 more. Well, I don't worry about it for one thing.
Right. Mm-hmm. So what is that? We watched it here more. 5.1 and 5.3. Mm-hmm. Yes.